Hello, hello, hello. Can you hear me? ಎಲ್ಲ PU2 ವಿದ್ಯಾರ್ಥಿಗಳು ನಮಸ್ಕರಿಸುತ್ತೀವಿ. ಬನ್ನಿ, ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಪ್ರಾರ್ಥನೆ ಸಲ್ಲಿಸಿ ಇಂದಿನ ಎಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರ ಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಕುಲದೇವರಿಗೆ ಪ್ರಾರ್ಥನೆಯನ್ನು ಸಲ್ಲಿಸಿ. Take deep breaths. Yes, good morning, my dear students. Welcome, Deepthi. Good morning. Good morning. Let us continue in the chapter Solutions. The second topic, after learning concentration of the solution, let us continue with the second topic. Second topic, that is solubility. What is meant by solubility? We will try to understand. Now see, suppose that you take a beaker, right? In one beaker you take water. In one beaker you take water, H2O. Suppose that you take in another beaker. In another beaker, say benzene, right? Benzene. You try to dissolve. Take sodium chloride salt, right? If you put it in water at a given temperature, say room temperature, and if you shake it well using a glass rod, what do you observe? So that you dissolve same sodium chloride in benzene, shake it with water, what happens at the given temperature? Now your observation is that sodium chloride after some time vanishes, right? And in benzene, sodium chloride cannot dissolve, it will settle at the bottom. Means what? We say that sodium chloride is dissolved in water. Sodium chloride is not dissolved in water. Not dissolved in water, it is dissolved in water. Now what is the meaning of it? Generally, when a particular substance taken in a small quantity, we say that it is a solute. Here solute is, a solution consists of two parts. We learnt in the beginning only. This particular solute, this is a solvent. When you put a solid, let us take solubility of, this is a solid, sodium chloride is a solid, and this water is a solvent, is a liquid, solute is solid. When you take a solid sodium chloride dissolved in water, after some, put it in water, after some time these particular sodium chlorides do not become visible. Then we say that sodium chloride is soluble in water. And here say that sodium chloride is insoluble in benzene. Why it is insoluble in benzene? why it is soluble in water? For that there is a principle. There is a principle of solubility. What do you mean by solubility? Solubility is the maximum amount of solute dissolved in a solvent at given temperature, at say constant temperature and pressure, at constant temperature and pressure, because this solubility depends on two factors. One is called as the temperature, another one is called as pressure. They are the factors that affect the solubility. What is the solubility? The maximum amount of the solute dissolved at dissolved in a solvent, the maximum amount of the solute dissolved in a solvent at constant temperature and pressure, or given temperature and pressure. This is called as solubility. Whenever you dissolve solute in a, say, solid in a, we'll see the solubility of a solid in liquid. Solid solute in a liquid solvent, we are going to study the solubility. Now what happens during this process? It is not, sodium chloride is not soluble in benzene. Sodium chloride is not soluble in benzene, but sodium chloride is soluble in water. You take oil now, or you can take toluene, any organic substance, or oil you can take. If you add oil to the water, it's a liquid, oil to the water, oil will not dissolve in water, it will float on the top. They are separated because oil will be lighter than, have density less than water, therefore it floats, and the oil is insoluble in water. But oil will mix with water, benzene. Why this happens? Observe that sodium chloride is, there is a principle of solubility. Solubility is based on the principle. The principle of solubility, in short, we can say that like dissolve in like. Like dissolve in like. What is the meaning of like here? Like here, see, in a solute there are two types of substances. One is called as polar solute. Polar means sodium chloride is ionic compound. Ionic compound, it has the positive ions and negative ions. Water is also polar in nature. What do you mean by polar? Polar means the particular molecule will have opposite charge centers. Similarly, water is considered to be polar. How the water is considered as polar? Observe here, oxygen end will have a negative charge. Hydrogen end will have a positive charge, because oxygen is more electronegative, therefore the electrons are pulled, shared electrons are pulled more towards oxygen, therefore oxygen end will get a slight negative charge, hydrogen end will get a slight positive charge. Therefore, water is a polar solvent. The meaning of like dissolve in like is, polar solutes can dissolve in polar solvents, polar solute cannot dissolve in non-polar. See, benzene, this particular benzene is a aromatic hydrocarbon, you studied in the first year, and this particular benzene is in liquid state. C6H6 is the molecular formula, liquid state. It contains only double bond and single covalent bonds, therefore it is a non-polar. Most of the organic compounds are non-polar. Sodium chloride is polar in nature, benzene is non-polar, therefore sodium chloride cannot dissolve with a non-polar. The meaning is that polar dissolves in polar, right? Polar substance dissolves in polar, polar dissolves in polar, non-polar dissolves in non-polar. That is the meaning of like dissolve in like. Non-polar dissolves in non-polar, non-polar means the solute. You see the solvent. The meaning is that the polar solute dissolves in polar solvent. Non-polar solute dissolve in non-polar solvent. That is the principle of solubility. I hope you understood the principle of solubility. Sodium chloride dissolves in water because both of them are polar. Oil dissolves in benzene because both of them are non-polar. Non-polar dissolves in non-polar. Polar dissolves in polar is the principle of the solubility. I hope it is clear to you now. Okay. Now we will continue the study. This concept is clear to you. That is, polar dissolves in polar and non-polar dissolves in non-polar. What happens? Let us see the case of sodium chloride put in water. What happens inside there? So why it vanishes? Where the solute particles went was a big question for many chemists. Sodium chloride is a, that white colored solid. With solid, after putting it, after some time, if you shake it well, it will vanish. Means where they have gone. Right? So what happens is, these particular solute particles, when they are put in water, this particular water will separate the particles. Means NaCl ions are separated into Na++ Cl- ion. The positive water molecule, this particular Na+ ions are surrounded by negative charge of the water molecule. So for that I take this one as a water molecule, oxygen, and completely surround it. Large number of molecules of water with the negative charge center will surround Na+ ion. Clear? And a large number of water molecules with their hydrogen end is positively charged, will surround Cl- ion. This will have positive charge, partial positive charge. Thus, the Cl- ions and Na+ ions are isolated, and as a result, ions Na+ ion is separated and Cl- ion is separated. This particular process is called as dissolution. What it is called as dissolution. Dissolution means these particular solute particles are completely separated. In case of polar in polar, separated, and now we say that sodium chloride is dissolved in water. That is the meaning of this particular dissolution, right? Now if you go on adding more and more solute, every solvent has got a capacity. Like each one of us has a capacity to eat. If I eat 2 rotis, I'll be saturated. After 2 rotis, if I eat 3 rotis, I will face the indigestion. Clear? So therefore, every solvent will have certain capacity to dissolve solute particles at a given temperature. Therefore, solubility depends upon 2 factors. One factor is the temperature, another factor is the pressure. Right? Means at a given temperature and pressure. Generally, a particular solvent will have certain capacity, certain volume of the solvent will have a capacity to dissolve solute in it. Right? That capacity itself is called as solubility. Right? And this solubility depends on 2 factors. One is temperature and the pressure. Now, during the process, what happens is, as you go on solving more and more solute, the particular solvent which can still dissolve, you add 1 spoon of sodium chloride, shake it well, it dissolves. you add second spoon of sodium chloride, it may dissolve. If you go on dissolving more and more and more solute in it, a stage is reached when what happens is, when even if you add more amount of the solute, it will not dissolve, it will be settled at the bottom. It is called as crystallization. Observe here. The solution which can still dissolve solute at a given temperature is called as unsaturated solution. What it is called as? Unsaturated solution. These solutions means unsaturated solution will have the solvent which can still dissolve. The solvent which can still dissolve more amount of the solute, still dissolve more amount of solute in it, more solute at a given temperature, at a given temperature is called what it is called? Is called unsaturated solution. What it is called as? Unsaturated solution. You can open the pen and paper, go on writing. Writing is very important. Unsaturated solution. Writing makes you perfect, reading makes you complete. Don't leave the habit of writing. Now, what is unsaturated solution? The solution, you can even say, the solution which can still dissolve more solute at given temperature is called as unsaturated solution. Very important. Now, if you go on adding more and more solute, a stage is reached when these particular crystals of sodium chloride will collide and settle at the bottom. That process is called as crystallization. What it is called as? Crystallization. Means the crystals will separate out. They will settle at the bottom. And now we say that, see, there is a stage is reached. Even if you add more sodium chloride in it, it cannot dissolve any more solvent, any more solute in it. Then we say that the solution is said to be what? A saturated solution. It is called as saturated solution. What do you mean by saturated solution? Saturated solution means a solution which cannot dissolve any more solute in it. You can say saturated solution. Saturated solution. What is a saturated solution? A solution which cannot dissolve. A solution which cannot dissolve any more. Cannot dissolve any more solute in it. Solute in it is called yes, saturated solution. Saturated solution. Saturated solution. See, the solutions are of two types mainly. One is saturated solution, another one is called as unsaturated solution, which can dissolve more solute in it, which cannot dissolve any more solute in it at a given temperature. Very important. At a given temperature. At a given temperature or at a constant temperature is called saturated solution. Means if you go on increasing the temperature, is called a saturated solution. Okay. I hope you understood what is saturated solution, what is unsaturated solution. After reaching the saturation, if you add excess of solute in it, the solute particles will collide themselves and settle at the bottom. This particular process is called as crystallization. Then we say that the solution is supersaturated. Then it is called as supersaturated. When the solution crosses saturation level, What happens when you eat more than the requirement? We will get omit, indigestion, omit. That is what happens here in super saturated solution. These particular solute particles will collide between themselves and settle at the bottom. This particular solution is called as supersaturated, and this during the process you can expect the crystallization. What it is called as crystallization. I hope you understood now. This particular reaction, how the reaction takes place is, once this particular saturated stage is reached, you see solvent, the solute, suppose that you have taken in this case the solid solute, and the solvent is liquid, right? Now the at this particular a stage is reached when at what rate solute dissolve in solvent to form a solution. This particular process we call it as a dissolution, right? And from the solution, excess of when it becomes supersaturated, these particular solute particles will collide themselves and the reaction will be reversed, and these solute particles in it will unite and form the solute back. This particular process is called as crystallization. At a particular stage, both dissolution and crystallization take place at the same rate. Then we say that this particular solution will be in the liquid state because solvent is in the liquid state, and then we say that it is in a dynamic equilibrium. Then it is in a dynamic equilibrium is reached. You know what is equilibrium state? Dynamic equilibrium. Observe. What is the dynamic equilibrium? What is the forward reaction? Solute, when put in solvent, it forms a solution, is a dissolution, forward reaction. What is the backward reaction? When the crystals cross saturation point, supersaturated, excess crystals will collide between themselves, settle at the bottom. This is called as crystallization, is backward reaction. When both the forward reaction and backward reaction are taking place, initially forward reaction will be very fast. After some time backward reaction begins, means from the solution crystals are separated, sodium chloride crystals are separated. The process is called as crystallization. Both these forward as well as the backward reactions are taking place at the same rate. Means rate of forward reaction become equal to rate of backward reaction. Then we say that particular process has attained dynamic equilibrium. Means both forward and backward reactions are taking place at the same rate. Then we say that this particular situation is said to be dynamic equilibrium, right? So this dynamic equilibrium, once the dynamic equilibrium is reached, now we say that this particular solution is in a dynamic equilibrium. And this equilibrium state, once the equilibrium state is reached, right? In equilibrium concept, there is a law called as Le Chatelier's principle. Le Chatelier was an industrial chemist. He gave a principle on equilibrium system. What do you mean by equilibrium system? Our entire body is an equilibrium system. See, the pH of the blood is always 7.4. Even though we are lot of changes are taking place, our body is an entire system of equilibrium, right? Our bodies will maintain the equilibrium. When our body is in equilibrium, we say that we are healthy. When the equilibrium is disturbed, then unhealthiness starts. What is illness? Illness causes whenever equilibrium of the body is disturbed. Are you getting me? Then our body will try itself. Our body will try itself to regain. Suppose that you feel very much tired, If you sleep for 1 or 2 hours, then at the sleeping hours, your body will attain itself, adjust itself and come back to the healthy state. Generally, most of the times will be healthy. Once you feel unhealthy means there is that equilibrium in our body is disturbed. That is what Lee-Chatelier principle states. Right? When a constant means a change in temperature, change in temperature, change in pressure, adding solute to it, as adding solvent to it, any disturbance takes place, right? Then this particular system will try to attain the equilibrium state back. Means if I increase the temperature, increase the temperature, the equilibrium will try to decrease it. Means increase the temperature, equilibrium will try. Suppose that this is in equilibrium at 25 degrees centigrade. If I increase the temperature, then the system will try to nullify the effect. Means to bring back to the 25 degrees centigrade. Our human body temperature is always 37 degrees centigrade. Whenever we get fever, it will cross 37 degrees centigrade. Are you getting me? And for that, again our body will try to, once the fever are gone, your body will again come to normal body temperature. Means our body is an equilibrium system. And average human body temperature is 37 degrees centigrade. Right? Always the system will try to attain. If I increase if the body temperature is increased, then body will work to decrease it to maintain it at 37 degrees centigrade. That is what Lee-Chatelier states. Right? It states that, you can note down those who don't know the statement of Lee-Chatelier principle. Right? The equilibrium system, when a constant means when a constant, he uses the word constant, means variable, constant, like constant like change in temperature, pressure, concentration of the solution. When a constant such as change in temperature, such as change in temperature, change in temperature, change in pressure, or change in concentration of reactant or product, change in concentration of a reactant or product, reactant and product, right? The equilibrium system will try to nullify the effect. The equilibrium system will try to nullify the effect and come back to the equilibrium state. Come back to the equilibrium state. That is what is the meaning of equilibrium state. ಏನು ಹೇಳಿಕತ್ತಾನ Lee-Chatelier ಏನು ಹೇಳಿಕತ್ತಾನಂದ್ರೆ, ಒಂದು ಸಿಸ್ಟಮ್ ಆಫ್ equilibrium reach ಆತ. Means at what rate solute are dissolving in solvent to form a solution, at the same state, at what rate dissolution is taking place, at the same rate crystallization is taking place, and this such a reaction is called as a reversible reaction. When both forward backward reaction are taking place, a stage is reached. When both of them take place at the same rate, then we say that equilibrium is reached. When the dynamic equilibrium, you see, this equilibrium is a dynamic. For an observer, it appears that the reaction is stopped. No, it is not stopped. It is a dynamic. What is the meaning of dynamic? Suppose that two fighters are standing here, right? They are pushing each other at the very high force. And for an observer, it appears that nobody is moving, but both of them are applying equal force to push other. For an observer, it appears that reaction is stopped. That is the meaning of dynamic. Dynamic means For an observer, reaction appears to be stopped. Temperature will remain constant, pressure will remain constant, concentration will remain constant at the equilibrium. But for an observer, the reaction appears to be stopped. It is not stopped. It is taking place in both forward direction as well as backward direction at the same rate. Therefore, we say that it is not a static. It is not a static. Static means stopped. Reaction is not static. It is dynamic. Such an equilibrium is called as dynamic equilibrium. I hope you are getting me. And what Lee Chetler said is that whenever you disturb, right, means whenever you get a problem, then what you do generally in your daily life, you meet some other person to solve that problem. If you find problem in mathematics, you will go and teach the mathematics, meet the mathematics teacher and get it solved. Again, you will come to the normal stage, non-stressful stage. If you have got any ill health, then you go to the doctor and balance it again. So like that, whenever this is equilibrium, dynamic equilibrium system is disturbed, Lee Chetler says that the equilibrium system, to maintain the equilibrium system, either the reaction, more reaction takes place in the forward direction or more reaction takes place in the backward direction and come back to the equilibrium state. Means it will try to be in the equilibrium state. ನಮಗೆ ಯಾವಾಗಲೂ ಆರಾಮ್ ಇರಬೇಕು ಅನಿಸ್ತದ. ಆರಾಮ್ ಇಲ್ದಾಗ ಮಲ್ಕೋಬೇಕು ಅನಿಸ್ತದನ್ರಿ, ಅನ್ಸೋದಿಲ್ಲ. We can't enjoy if we are not healthy. ನನಗೆ ಆರಾಮಿಲ್ಲ ಇವತ್ತು, ಏನೂ ಆಗವಲ್ದು ಅಂತೀವಿ. ಆರಾಮಿಲ್ದಾಗ ಯು ಫೀಲ್ ಅನ್ಈಸಿನೆಸ್. ಮೀನ್ಸ್ ಅಂದ್ರೆ ಆರಾಮ್ ಇರೋದು ಯಾವಾಗಂದ್ರ, ಯಾವುದೇ ರಿಯಾಕ್ಷನ್ ಆರಾಮ್ ಇರೋದು ಯಾವಾಗಂದ್ರ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಸ್ಟೇಟ್ನಾಗ ಇದ್ದಾಗ. ಡಿಸ್ಟರ್ಬ್ ಆತಂದ ಕೂಡನ ಏನ್ ಮಾಡ್ತದ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂದ್ರ, ಐದರ್ ಇಟ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಇನ್ ದ ಫಾರ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಆರ್ ಇಟ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಇನ್ ದ ಬ್ಯಾಕ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್. ಇದಕ್ಕೊಂದ ದಾರಿ ಇರೋದು ರಿಯಾಕ್ಷನ್ಗೆ. ಇಲ್ಲ ಫಾರ್ವರ್ಡ್ ಬ್ಯಾಕ್ವರ್ಡ್ ನಡೆದು ಏನ್ ಮಾಡ್ತದ, ಮತ್ತು ಅದ ಟೆಂಪರೇಚರ್ ಅದ ಪ್ರೆಷರ್ ಸೇ 25 ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡ್ ಅದ ಅಂತ ತಿಳ್ಕೊಡ್ರಿ, 2 ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಪ್ರೆಷರ್ ಒಳಗೆ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಅದ ಅಂತ ತಿಳ್ಕೊಡ್ರಿ. ಇದ ಸ್ಟೇಟ್ ನಾ ಟೆಂಪರೇಚರ್ ಹೆಚ್ಚಿಗೆ ಮಾಡಿದ್ರ ಟೆಂಪರೇಚರ್ ಕಡಿಮೆ ಮಾಡ್ಕೊಳಿಕ್ ಬರ್ತದ, ಪ್ರೆಷರ್ ಹೆಚ್ಚಿಗೆ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಏನ್ ಮಾಡ್ತದ, ಪ್ರೆಷರ್ ಮತ್ತೆ ಕಡಿಮೆ ಮಾಡಿದೆ. ಸೇ ಟೆಂಪರೇಚರ್ ನಾ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದೆ 30 ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡ್ ಮಾಡಿದೆ ಅಂದ್ರೆ ಹೊಳ್ಳಿ 25 ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡ್ ಮಾಡ್ಕೊಳಿಕ್ ಅದು ಟ್ರೈ ಮಾಡ್ತದೆ ಇಕ್ವಿಲಿಬ್ರಿಯಂ. ಅದನ್ನ ಮಾಡೋ ಸಲುವಾಗಿ ಐದರ್ ಇಟ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಇನ್ ದ ಫಾರ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಆರ್ ಇಟ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಇನ್ ದ ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್. ಸಪೋಸ್ ನಾವು ಪ್ರೆಷರ್ ಏನ್ ಮಾಡಿದೆ, ಕಡಿಮೆ ಮಾಡಿದೆ, 1 ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಮಾಡಿದೆ, ಮತ್ತೇನ್ ಮಾಡ್ತದ, ರಿಯಾಕ್ಷನ್ ಈ ಕಡೆ ನಡೀತದಲ್ಲ, ಯಾ ಕಡೆ ಅದರದ್ದು ಪ್ರೆಷರ್ ಮತ್ತು 2 ಅಟ್ಮಾಸ್ಫಿಯರ್ ಆಗ್ತದೆ. ಮೀನ್ಸ್ ಎವ್ರಿ ಡೈನಾಮಿಕ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಸ್ಟೇಟ್ ವಿಲ್ ಟ್ರೈ ಟು nullify the effect when a constant such as change in temperature, change in pressure, change in concentration of reactant or product is applied to a equilibrium system, is applied to an equilibrium system, the equilibrium will try to nullify the effect and come back to the equilibrium state. This is a tendency observed by Lee Chetler according to Lee Chetler principle. Now we will see, we have got a dynamic equilibrium. Now I will write the dynamic equilibrium of a solution of a solid solute in liquid solvent. Means solid in liquid, like sodium chloride in water. Now the solvent, now let me take solute is in solid state. Now we have solvent in liquid state. I will write the reversible sign. This is solute, solid, plus a solvent, liquid, and this is a reversible process. Forward reaction is the dissolution, backward reaction is crystallization, and you will get a solution. This solution will be in which state? This solution will be in the liquid state. Okay. Suppose that this particular forward reaction is endothermic, means enthalpy of heat of the products, or it is having plus heat. Whenever you write plus heat on the product side, means that it is exothermic or endothermic. It is exothermic. Suppose Exothermic. For example, when you dissolve sodium chloride in water, right? And suppose that it attained equilibrium here, you will get a sodium chloride solution or Na plus ions, aqua plus Cl minus aqua, and it will absorb heat energy which is equal to minus 5.45 kilojoule. This minus sign indicates it is endothermic. What it is called as endothermic. Means that much of heat energy is absorbed. I will take another example. If you take sodium hydroxide, 5.45 kilojoule per mole, that much of heat energy is absorbed. Sodium hydroxide solid, when it dissolved in water, suppose that it attained equilibrium, then you will get here Na plus aqua plus OH minus, it will ionize. It will liberate heat energy of 42 kilojoule per mole. You go to the laboratory, take a test tube, right? Take a distilled water in it, add sodium chloride and shake it well and hold the test tube, you feel colder. You add sodium hydroxide in another test tube, and shake it well, you will feel hotter, because dissolution of sodium hydroxide in water is exothermic reaction. Generally, exothermic reactions are written with a positive sign on the right hand side. Endothermic reactions are written with a negative sign on the product side. Now, forward reaction is dissolution. Forward reaction means dissolution is endothermic. Now, we will see the effect of temperature on the equilibrium system using Lee-Chatelier principle. Effect of temperature, right? Suppose that I increase the temperature now. I increase the temperature of the solution. What happens? What happens in this case? What happens in this case? According to Lee-Chatelier principle, when I increase the temperature, okay, let me rub this part. When I hope you understood these things. I will rub this so that you can clearly understand. See, in the first case, effect of temperature on the dynamic equilibrium of a solid solute in a liquid solvent. The solution will be in liquid state. And it may be plus or minus heat. I have taken in particular example, sodium chloride when dissolved in water, heat energy is absorbed. Therefore, it is endothermic. This is endothermic. Heat energy absorbed. And sodium hydroxide dissolution in water is exothermic. 42 kilojoule per mole of heat energy is liberated. Therefore, it is exothermic. Exothermic means heat energy liberated. Heat liberated. Try to understand clearly. Lee-Chatelier principle. Right? Suppose that I increase the temperature. Temperature increase ಮಾಡಿದೆ. Forward reaction ಏನದರಿ? Forward reaction ಏನದ? It will absorb the heat energy. ಇಲ್ಲಿ ಏನದ? Forward reaction ಏನದ? It will liberate the heat energy. When I increase the temperature, in this case, if the reaction is endothermic, forward reaction is endothermic. So when the temperature is increased, according to Lee-Chatelier principle, that increased temperature must be what? Must be absorbed. Suppose that it is at equilibrium at 25 degrees centigrade. If I increase the temperature to 50 degrees centigrade, heat the test tube containing sodium chloride solution. If I heat it, what do you observe? Up to 50 degrees centigrade. Now to come back to the equilibrium, whatever increase in the temperature is there, it should be absorbed. To absorb the heat energy, the equilibrium has got only one solution. Either more forward reaction should take place or more backward reaction should take place. So what is your guess? When the temperature is increased, according to Lee-Chatelier principle, to nullify the effect means excess at 25 degrees centigrade is to be absorbed. Remember, if the forward reaction is endothermic, backward reaction will be exothermic. Right? If the forward reaction is exothermic, backward reaction will be endothermic. Means during formation of a product, X amount of heat energy is liberated. Same amount of heat energy should be absorbed to give back the reactant. That is another important rule in it. Means in order to nullify the effect, do you think this forward reaction is endothermic, means backward reaction will be what? Exothermic. Means excess to absorb excess of heat energy, do you think more dissolution takes place or more crystallization takes place? Think. To absorb heat energy, excess of heat energy, then a forward reaction is endothermic, means reaction will take place in the forward action and nullify the effect. If the reaction is endothermic, when temperature is increased, to nullify the effect, ಏನಾಗ್ತದೆ? to nullify the effect, more reaction takes place, in what? In such a direction, more reaction takes place, in a forward reaction, or more dissolution takes place. More dissolution takes place. More dissolution of solute takes place. Are you getting me? Means equilibrium shifts to what? Right. Means effect of temperature is, if the reaction is, if the dissolution is, or solution is, the solution is, forward reaction of the solution is endothermic, like sodium chloride in water is endothermic. Then if you increase the temperature, reaction, more dissolution takes place and equilibrium will shift to the right. In the second case, if the reaction is exothermic, what do you expect? If the reaction is exothermic, or the same endothermic reaction, I will finish it first. Endothermic reaction. Try to understand the concept. When the temperature is increased, equilibrium shifts to what? Forward direction. Forward means from left to right. If the temperature is decreased, what happens? When the temperature is decreased, now you can easily guess. When the temperature is decreased, suppose that or sodium chloride in water is the equilibrium as 25 degrees centigrade. If I cool it to 10 degrees centigrade, again to gain at 25 degrees centigrade, the reaction should take place what? Backward reaction, because forward reaction is endothermic, then backward reaction will be exothermic. When the temperature is required, the more reaction takes place in backward direction, means more dissolution takes place here, and here more crystallization takes place. According to which principle? Le-Chatelier principle. Right? That is the effect of temperature of a solid in a liquid solution. You will be asked, explain what is the effect of temperature on a solution of solid in liquid in dynamic equilibrium. When the temperature is increased, forward reaction is endothermic, right? That to nullify the excess heat, more endothermic reaction should take place. Therefore, equilibrium shifts to right. Means more dissolution takes place. I hope it is clear now. I hope it is clear now. Okay. Now, if the temperature is decreased, say I cool it to 10 degrees centigrade, again to come back to 25 degrees centigrade, backward reaction takes place. Backward reaction takes place. So that more crystallization takes place. I hope you understood. Is it clear? That is the effect of temperature. You will be asked effect of temperature, effect of temperature. I think I made you very clear. So, effect of temperature on the solubility of a solid in liquid is, if the forward reaction is endothermic, when the temperature is increased, right, to nullify the effect, more forward reaction takes place, so that heat energy will be absorbed, again equilibrium will be maintained. If the temperature is decreased, right, decreased 10, to nullify the effect, when the forward reaction is endothermic, backward reaction crystallization will be exothermic. Therefore, when the temperature is increased, to increase the temperature, backward reaction takes place. That is the effect of temperature. If the reaction is exothermic, see, I have given both the examples. Exothermic. I have given exothermic reaction here. Sodium hydroxide dissolved in water, forward reaction is exothermic. We write in the equation as plus 42 kilojoule per mole. Now, can you guess what happens when temperature is increased? Temperature is increased. Temperature is decreased. Now, guess. If you understood the concept, guess it. If the temperature is increased, if the reaction is exothermic, and temperature is increased, what do you expect? See, forward reaction is exothermic. When the temperature is increased, backward reaction will be what? Endothermic. Right? Now, when you increase the temperature to absorb excess of heat energy, in case of sodium hydroxide, do you think crystallization takes place or more dissolution takes place? Backward reaction takes place. Which reaction? Backward reaction takes place, means more crystallization takes place. More crystallization takes place to absorb the increased energy. If the reaction is, solution is endothermic, exothermic, sodium hydroxide is exothermic in nature. If the temperature is decreased, in which direction reaction takes place? Is forward direction. Why? When the temperature is decreased, for the system to increase the temperature, more exothermic reaction is takes place. Therefore, forward reaction takes place, and that is dissolution will take place more. This is the effect of temperature on the dynamic equilibrium of a solution of solid solute in a liquid solvent. I hope the concept is clear to you. Okay, fine. What is the effect of pressure? What do you think? Effect of pressure? See, remember, effect of pressure. Generally, the term pressure corresponds to what? You talk of pressure of what? Only gases. Why? See, what is the difference between solid, liquid and gases? You try to understand. I will make you clear. Right? I will take a solid sodium chloride here. I will take a solid crystals of sodium chloride. I will take water here, and I will take in a beaker, right, hydrogen gas. Here, water in a beaker. What is the difference between solid, liquid and gas? If you apply more pressure on it, solids cannot compress, because already they are very compact, closely packed. Sodium chloride crystals are closely packed. Water is liquid, and if you apply pressure on this particular liquid, and it will not decrease up to its its volume will not decrease. Are you getting me? Because according to Boyle's law, at a given temperature, volume is inversely proportional to pressure. As you increase the pressure, volume should decrease. It is applicable only for water, gases. Therefore, if the solute is solid and liquid, generally pressure has no effect on it. Pressure has got effect only on what? Gases. Therefore, you can conclude that, right, in a solid and liquid solute, in a solid, in a dissolution, in a dissolution of, in a solubility, you can say, in solubility of solid solute and liquid solute, change in pressure has no effect. Change in pressure, remember this, change in pressure has no effect on it. No effect on it. I hope you understood this. Because this effect of pressure is only applicable to the gases. Only applicable to the gases. Clear it to you? Only applicable to the gases. So therefore, what happens when a gas is dissolved in liquid? Gas is dissolved in the solution of a gas in a liquid. We'll see in the next class. There is a law called as Henry's law. About that we will discuss in the next class. That's all for today, my dear students. Watch Lokji channel and invite your friends. This channel is created to clear the concepts. If the concepts are not clear, you can ask me again and again. Right? We'll meet tomorrow with tomorrow I think we completed inverse trigonometric function. Be ready to write a test. Right? Today night only, I will send you a question paper of 20 marks, 45 minutes. Right? Late night you write it and keep it ready. Early morning at 6:45, I will solve the problem on inverse trigonometric function. After completing that, I will start matrices. Okay? And tomorrow you have maths test. Remember, I will send you in the WhatsApp group. And next period we will continue with the solutions. You make it perfect. Study the textbook and attend the class with the pen and paper. Have notes. Writing is very important. Don't just watch it. With the pen and paper, watch these classes. And tonight after late night 10 o'clock, I will send you the paper and don't open it. Morning, whenever 45 minutes time you get, even night also 45 minutes time you get, you study. By 7:30 or by 8 o'clock I will send you. Between 7:30 to 8 I will send you the paper. 45 minutes you write it and keep it ready, and don't copy, and be sincere. And I will be discussing the paper with scheme of evaluation. Then you have to evaluate and send the marks in the group. And I will or your paper, photo of the paper, and along with the total marks you send. And that is offline test taken here with followed by discussion. Right? That's all, my dear students. Bye bye. See you tomorrow morning for a discussion of the paper. I will send in the evening today. Tomorrow morning at 6:45. Bye bye. See you.